Hello everyone, this is Afifa Anjum. Today I'm going to explain about molecular orbital theory. Definition of the molecular orbital theory. Molecular orbital theory explains chemical bonding by assuming that atomic orbitals combine to form molecular orbitals which spread over the entire molecule and electrons occupy these orbitals according to energy levels. Then explanation of the molecular orbital theory. Molecular orbital theory is a modern theory used to explain chemical bonding in molecules. It was developed by F1 and Robert Mulliken. According to this theory, when atoms combine to form a molecule, their atomic orbitals do not remain localized around individual atoms. Instead, they combine or overlap to form new orbitals called molecular orbitals, which are spread over the entire molecule. This that means that electrons are not restricted to one atom but belong to the whole molecule. Thus, molecular orbitals describe the region in space where electrons of the molecule are likely to be found a bit of it. Then LCAO, which stands for linear combination of the atomic orbitals. Molecular orbitals are formed by linear combination of the atomic orbitals. When atomic orbitals of similar energies and proper symmetry overlap, they combine to form two types of orbitals: bonding molecular orbital and anti-bonding molecular orbital. The bonding molecular orbital results from constructive overlap where electrons density increases between the two nuclei, means two atoms. This type of orbital is lower in energy and leads to a stable bond between atoms. On the other hand, the anti-bonding molecular orbitals is formed by destructive overlap where the electron density decreases between nuclei. This orbital has higher the energy and contain a nodal planes, making the molecule less stable. There are mainly two types of molecular orbital based on the type of overlap: sigma orbitals and pi orbitals. Sigma molecular orbitals are formed by the end to end or head on overlap of atomic orbitals like s bond s, s bond p, or p bond p. These are known as axial overlaps. Sigma bonds are stronger and allow free rotation around the bond axis. Pi molecular orbitals are formed by side to side overlap between two parallel p orbitals. Pi bonds are weaker compared to the sigma bonds and restrict rotation because the electrons clouds lie above and below the internuclear axis. Postulates of the molecular orbital theory. Molecular orbital theory are formed by the combination of atomic orbitals of the bonded atoms. These orbitals belong to the entire molecule, not a single atom. The number of molecular orbitals formed is equal to the number of atomic orbitals combined. Atomic orbitals combine only if they have comparable energy and proper orientation to overlap and effectively. Molecular orbitals are formed by two types of overlaps: constructive overlap and destructive overlap. Constructive overlap belongs to the bonding molecular orbitals, in which lower the energy which is very stable. Destructive overlap belongs to the anti-bonding molecular orbitals, which are high in energy and unstable. Electrons in the molecular orbitals are filled according to the same rules as the atomic orbitals of the principle. Low energy orbitals filled first, and Hund's principle, as known as Hund's rule, orbitals of equal energy are filled singly the first before pairing. Bonding molecular orbitals increase stability while antibonding orbitals decrease the stability to the molecule. The difference in energy between bonding and antibonding orbital determines both strength and stability. Types of the molecular orbital theory. When two atomic orbitals combine, they form two molecular orbitals. One is bonding molecular orbitals and second one is anti-bonding molecular orbitals. As we discussed these two molecular orbitals in the before page, And next, bond order. Bond order means um, the two equals to b minus a by 2. B is equals to number of bonding electrons, a equals to number of anti-bonding electrons. Next, advantages. Explain It explains the magnetic properties of the molecules, accurately determines bond order, and predicts the molecular stability, explains bond length, and it also explains about the bond strength. It is applicable to the both homonuclear and heteronuclear molecules, describes formation of the molecules and the ions clearly. It differentiates between bonding and anti-bonding orbitals very clearly, and it is useful for understanding electronic spectra and transitions. And it explains the bond strengths and the bond length. And next, applications of the molecular orbital theory. Determination of the bond order. Applications means where we use the molecular orbital theory. And second one is prediction of the molecular stability. It explains about magnetic properties like paramagnetism and diamagnetism of the molecules, which are formed by the uh, two atoms or more than two atoms. Determination of the bond length and bond strength. Explanation of the formation of molecules and ions. It identifies of single, double, and triple bonds. And then prediction. It predicts the electronic transitions. Transition means d block elements. It only applicable for transition elements, which means d block elements, which belongs to the d block elements. And then understanding chemical reactivity study, then it's study of the molecular spectra, and it also known as a spectroscopy. It is the study of the molecular spectra. Explanation of molecular orbitals diagrams for different molecules, and it also determines the bond length and bond strength very easily. And it also identifies the single, whether the molecule has a single bond and or double bond or triple bond very easily. And it is only applicable for transition elements, which are known as the d block elements also. And then the limitations. Mathematical, it also limitation means where we use the molecular orbital theory. Mathematical calculations are complex. Limitations: difficult to apply without quantum mechanical knowledge, less effective for very large molecules, does not clearly explain the concept of the resonance, cannot easily predict the exact shape of molecules, requires advanced computational methods for accurate result. And then it also does not clearly explain the concept of the resonance. It don't explain the molecular orbital theory, don't explain about the resonance of the molecule very clearly, means that accurately that we want in the way. And then it cannot easily predict the exact shape of the molecules, because we need the shape of the molecules to memorize. So it cannot, molecular orbital theory cannot predict the exact shape of the molecules. Then mathematical calculations are complex. It requires the advanced, and it also require so much advanced computational methods for accurate result. For the fast result, it should acquire computational methods. And thank you for, that was my class.